Look at the backside of your worksheet here in the last two problems. Some application problems of these shifted geometric sequences. So on number 4 it says the northern population in a certain lake in Wisconsin is under the DNR's jurisdiction. Its research indicates the population is decreasing at a rate of 20% per year. I'm going to just underline that decreasing part because that's going to be important. The DNR proposes to introduce 1,400 additional northern each year to replenish the lake. Assume that the current population is 2,500. So I'm kind of underlining some key pieces that are going to help me with part A here, which is to write the recursive equation for this situation. So recursive again, u sub 0, what's our starting population? Well, it said current, okay, so what is it now? Current population is 2,500 northern. So what are we doing to try to maintain this population? So u sub n equals u sub n minus 1. Well, unfortunately, it's decreasing at a rate of 20% per year. Either lots of northern are being caught out of this lake, they're dying off, whatever the reason is. So I'm going 1 minus 0.20. If you write here 0.8, I am fine also. And actually, I prefer that. Then, however, the DNR here are adding northern to try to replenish it or keep the population at a certain level. In this case, they're adding 1,400 northern. Now, we have our recursive definition. We want to figure out the population long run. So to show the long run value, again, we take the, in this particular case, the adding amount and divide it by the percentage of decrease. So in this case, 1,400 divided by 0.2, because it's going down by 20% each year. And if we do this over the long run, the DNR hope to have 7,000 northern in this lake on a consistent year-by-year basis as long as they continue to do this. All right, number 5, last problem on this worksheet here. It says the moose population, so similar to the trout, or not trout, what am I saying, trout, the northern population. So the moose population here in the Boundary Waters area in northern or North Minnesota is under the DNR's jurisdiction. Same type of problem, just different context. So research indicates the population is decreasing at a rate of 5% per year. The DNR proposes to introduce 25 additional moose to the area every year. Assume the current population is only 100 moose. I don't know if you saw on the news, but this is actually something that's seriously happening right now in northern Minnesota. So, u sub 0 equals the starting moose population, 100. U sub n equals u sub n minus 1. Now the population is decreasing by 5%. So if you put 0.95 here, you're good to go. However, the DNR, I forgot to underline this, are adding 25 moose per year. So, we have our recursive definition. Part B then, again, asks for the long run value. So long run value, again, is the adding amount divided by the percentage of decrease. So we were adding 25 moose. It was decreasing by 5% each year. Type that into your calculator and you get 500 moose. All right, so that ends page 2.